In the previous lessons, you used the integrated encoders to have the robot move straight forward until it traveled a specific distance. You may have noticed, though, that sometimes the robot's momentum carries it past where it should stop. In this video, you will program your robot to slow to a stop using the Move Motor Target and Get Motor Target Completed commands. Our program with these new commands will work differently than our previous programs with the Get Motor Encoder command. The Get Motor Encoder command uses a while loop to move the robot forward until the value of the encoder is greater than the specified encoder counts. Once the robot reaches this distance, the robot coasts to a stop. The Move Motor Target command uses built-in functionality in RobotC's firmware to monitor the value of an encoder and automatically slow the motor down as it approaches the target value. These two commands are similar to two types of drivers approaching a stop sign. A bad driver, such as Get Motor Encoder, will slam their brakes when they reach the stop sign and travel into the intersection. A good driver, such as Move Motor Target, will slow down as they approach the stop sign and come to a complete stop directly in front of it. Let's take a look at the new type of program. In RobotC, go to File, Open Sample Program. Open Integrated Encoders and select Forward for Target Distance. In Task Main, the first command is a wait for 2 seconds, directly followed by two Move Motor Target commands. Notice that the values of the integrated encoders are not reset. This is because the Move Motor Target commands take the current encoder readings into account when moving the robot the desired distance. The Move Motor Target command allows you to specify 4 settings. The motor with the integrated encoder to use. The target number of encoder counts to move. The maximum speed the motors can use. And whether the motor should brake versus coast at the end of the movement. In this program, the left and right motors are set to rotate for 1800 encoder counts at a maximum speed of 63, with braking set to true. These two commands provide all of the information that the robot needs to move to a target distance. But if the program ended here, the robot would never actually go anywhere. The robot needs time to complete the movement before the program ends, stopping the motors. Now, we could use a simple wait 1 millisecond command here, but we would run the risk of providing too few milliseconds, cutting the movement short, or too many milliseconds, wasting time. Instead, the program uses two Get Motor Target Completed commands to intelligently check if the specified motors have reached their targets. The Get Motor Target Completed command is equal to false when the motor specified in the parentheses is still spinning, and true once it has come to a stop. In order to continually check the state of the motors, the Get Motor Target Completed commands are used as the condition in a while loop. By checking if the Get Motor Target Completed commands are equal to false, the while loop is essentially asking, have the motors finished their target movements yet? Notice that there is no other code to execute inside of the loop. This is called an idle loop. An idle loop repeats an empty body of commands, keeping the robot at that spot in the program until the condition becomes false. You may not be familiar with the vertical slash symbol, however. Two vertical slash symbols form the OR logical operator. This Boolean operator is used to combine two or more conditions. Using the OR operator, the overall condition is true if the first condition or the second condition is true. The overall condition only becomes false once both conditions are false. For more background information on logical operators, you can watch the Boolean Values Helper videos. The program will continue to loop until getMotorTarget completed for both motors changes to true, allowing the robot to reach the target distance. Let's try it out. Compile and download the program and run it. Your robot moves forward in a straight line and slows to a stop after 1,800 encoder counts. You now know how to take full advantage of the capabilities enabled with the integrated encoders.